This is an extended writing question, so structure is important, as are links. Read the question really carefully, and once you've answered it, check back that you've answered all of it. Remember, comparisons, conclusions, things like that are going to get you the marks here. This question is a good one for practicing our response when we see this little asterisk, or however they tell you it's a quality of written communication question that you're answering. What I'm going to suggest to you when you're answering quality of written communication questions is when you read it, that you try and see the clues of what's going to be in that mark scheme. 6 marks. There's going to be at least kind of 4 to 6 kind of points that you're going to make. And importantly, the last 2 of these are for the structure of your writing. And in A Level, we're talking about linking points. So don't just start writing straight away when you see Millikan's oil drop experiment. This is what this one is, basically. Take your time and think and have a little plan in your head of how you're going to write in what sequence. So let's read together. In an experiment determine the charge on an electron, negatively charged oil drops are allowed to fall between 2 parallel metal plates, that's these, separated by distance d. A potential difference is applied across the plates, so this one's positive and this one's negative. Okay, so there's a PD between them. The diagram shows 1 oil drop, there it is. When the PD is 0 volts, the oil drop accelerates to terminal velocity. Right, so first clue is this bit here, 0 volts, terminal velocity. The PD is increased, and it observed that at a particular PD, V, the oil drop stops falling and remains stationary. Remains stationary between the plates. Now these should give you a clue to the situations this is getting at. Explain the motion. I'm thinking about forces if I'm talking about motion, aren't I? In terms of the forces acting on it, as the PD is increased from 0 to V, to whatever the voltage is, that it remains stationary. Well, think about these two, before you answer it, think about these 2 situations. V term, well, we know that is the situation where something's weight equals the drag on it. It's falling, so it's got a drag, so W equals D. And then laterally, it remains stationary, so there's no drag on it, there's still its weight. But instead, there is an electrostatic force, which I'm just going to call F, because it is attracted to either of these sides. And well, you can see which way around it is, and you know it's an electron. It's a negatively charged ion, so you know that it's attracted upwards to there when there's a PD on it. So you've got your 2 situations, you've got stationary secondly, and you've got V term first. So you've just got to try to kind of explain that. So firstly, let's talk about it when it is at V term, okay? So accelerates the oil drop until the drag force equals the weight. Okay? We're just saying the forces are balanced. It's a Newton 1 pair. You don't need to talk about Newton 1, but you should be, anytime you're talking about forces, you need to be thinking in terms of Newton's laws. What happens next? Well, next they increase the PD. So as they increase the PD, then there's going to be an electrostatic force upwards. So what's going to happen there? That's going to decelerate. Okay, it'll decelerate until such a point which there's a new Newton's first law pair where weight equals the electrostatic force. maybe I haven't put this in the right order here. Weight equals the electrostatic force. Okay, but I can still rescue this by saying that that electrostatic force will equal the weight at potential difference V. Okay, and then the oil drop will remain stationary because the forces are balanced. Or in other words, it's Newton's first law. Sum of the forces is 0, therefore acceleration equals 0. Okay, I hope that makes sense. The quality of written communication mark is for linking the points together. So as the experiment increases the PD as the electrostatic force upwards, the oil drop will therefore decelerate. So linking the upward force with deceleration. It decelerates until a point where weight equals electrostatic force. This electrostatic force will equal the weight at PdV. So in other words, they're increasing it towards that. I think maybe that's the bit I could have, this is the bit if I thought about it a little bit longer, I could have made that order a little bit better. But hopefully you've been able to think, well, how am I going to pick up maximum marks? By using the clues in the question. Okay, this next one, whenever you are given the task of deriving an equation, go to the equation sheets because you will be given the bare bones that you need to derive that equation there. And the bare bones that you need in this case, well, you can see mg there, the oil drop. We're talking about the situation here where W equals electrostatic force F. Okay, and actually if I'd have written that, I'd have got one of these 2 marks because one of the marks is for equating the weight and the electrostatic force. You see mg there, so well, weight equals mg. That's my first description. Don't really need to look that up, but it is in there somewhere. In an electrostatic field, in an electric field, then this equation relates to electric field strength and the force and the charge. Okay, and then lastly, well, what is that E? What does E represent? Is V over D, the potential difference divided by the plate separation. So now I hope you can kind of see where these bits are going to come from. I've got mg from this, I've got V and D, or the ratio between them, but inverted there, and I've got Q in there. So first thing to do is to rearrange these so I can equate them. Well, I've already got F equals mg, so that's fine. So rearrange that for F EQ. I can use little q as the charge of an electron, but it doesn't really matter. So now I'm going to say mg equals EQ, and now simply just sub in what E is. So mg equals V over dq, and simply rearrange for that. So I want q on its own. So what I can do is divide both sides by V over d. So I get mgd over V equals Q. Okay, hope that makes sense. That's just algebra. I'm sure you could do that. Know your equation sheet well and you'll be fine with that. Explain what will happen to the oil drop if the PD will increase further. So if the PD increases further, the weight's not going to change, but the force is. Well, it's going to accelerate then, isn't it? and it's going to accelerate upwards in the direction of that force. Okay, why is it going to accelerate upwards? Because the electrostatic force is now greater than weight. So without mentioning it, this whole question has been about Newton's laws, hasn't it? Because now you've got a Newton 2 situation where the force is, there's a resultant force, so you get an acceleration on your mass. Okay, I hope that helps you understand that question. So I hope that was really useful to you. Exam questions are a great way to practice for exams, but don't just do exam questions. If you struggle with that exam question, then you probably need to revisit the theory for that topic. So do that before you have a go at some other ones. If I've made any mistakes, then correct them down below. And if you've got any more questions, then down below as well. Maybe you guys can help each other out. And there should be some playlists around here and a subscribe button if you like that and you want to see some more as and when I bring it out. All right, thanks a lot for watching.